In the previous lesson, we looked at the purpose of the provisional family of responses. In this lesson, we'll focus on the first member of the provisional family, the 100 trying. By the time we're done, you should understand the purpose of the 100 trying and perhaps more importantly, how SIP has its own built-in mechanism for reliable delivery. So, a quick revision question then. What is the purpose of the 100 trying? It's an update report on how the request is being fulfilled. It says, I've received the request and am trying to do something about it. But why does the upstream user agent client need to know that his request has arrived? Can't we just take it for granted that it has? Well, let me ask you something. Which transport protocols could be used for delivering SIP packets across the IP network? Have a think and press play when you're ready. The answer? Well, there are two IP transport protocols that come to mind. There's TCP and UDP. TCP, the Transmission Control Protocol. Now, applications use TCP to manage delivery of IP data over the network. Before sending the data, TCP checks with the other side to make sure it's ready to receive the packet. Knowing that it is, TCP then sends the packet out over the network. Now, it might be that the packet does not get through. Maybe it's dropped from an overloaded router's buffer. Perhaps it's corrupted on its way downstream or something. What now? Well, TCP makes some checks. Did you get it? No. Oh, then I'll send it again, and a copy of the same packet is automatically resent out over the network. Did you get it this time? Yes. Great. Despite network-level problems, the packet is delivered reliably from client to server, the application being oblivious to network-level problems. Sounds good. TCP is a reliable transport protocol. It takes care of retransmissions so that the application above doesn't have to. But there's something else to know about TCP. It needs a significant time overhead to prepare the connection and check that everything's delivered as expected. Now, the other transport protocol is UDP, the User Datagram Protocol. Now, UDP has a different approach to packet delivery. When it receives some data to transport over the network, it says to itself, well, I'll send the data, but I really don't care what happens, whether it arrives or whether it doesn't. So, what about lost packets? What happens to them? Well, with UDP, they're lost. UDP does not retransmit lost packets. It has a send and forget mentality. UDP is an unreliable transport protocol. Lost packets are lost packets. So why would anyone want to use UDP? Because it's fast. Unlike TCP, there's no setup time to prepare the connection. So with that in mind, which do you think is the default transport protocol for SIP? The slower, reliable protocol or the faster, unreliable protocol? Well, the default transport protocol for SIP is UDP, the faster but unreliable protocol. Unreliable? Does that seem strange? What if an invite request gets lost on its way? Without reliable delivery, the request will never arrive and the call will never get set up. Worry not. SIP has its own built-in mechanism for reliable delivery, a mechanism that's dependent on the 100 trying. Here's how it works. After sending out a SIP request, the user agent client, the UAC, sets a timer. Then, if the request gets lost and nothing comes back before the timer expires, the UAC knows a delivery problem has occurred, so resends the request, or a copy of the request, resetting the timer as it goes. This time the request arrives just fine, and so to be polite, the user agent server, the UAS, sends back a 100 trying to say, I've received the request and I'm trying to do something about your invite. But the network is having a bad day today, and the response gets lost on its way back upstream. What now? Well, the second timer expires, triggering the upstream user agent client to send the invite a third time, again resetting the timer as it goes. The downstream user agent server, recognizing the retransmitted request, also retransmits the 100 trying. Successfully arriving upstream, the UAC heaves a sigh of relief. I'm happy now. I know my request has arrived and I don't need to retransmit anymore. So, the purpose of the 100 trying, it's to confirm reliable delivery of a request. It's part of SIP's built-in mechanism for reliable delivery. Oh, by the way, any response that comes back confirms reliable delivery, not just the 100. The thing is, the 100 trying is used where there's nothing else yet to report about the fulfillment of a request, other than simply the request has been received. Okay, 100 trying responses and reliable delivery. The purpose of the 100 trying is to report reliable delivery of a request. We need it because SIP uses UDP as its default transport protocol, and we know that UDP is an unreliable transport protocol. It's a send and forget protocol. It doesn't care if packets get lost. SIP uses it though because it's fast. SIP's reliable delivery mechanism depends on a user agent client setting a timer after sending a request. If nothing comes back before the timer expires, the request is resent.